Hello everyone, my name is Subhasis. In today's video, we are going to cover how to create an ML pipeline using Kubeflow. In the last video, we covered a complex topic where we called the ML pipeline based on Kubeflow from Airflow DAG or Airflow pipeline. Let's focus on today's video. I'll share my screen. The code repository, the base code repository is workflows orchestration. We have covered Astronomer Airflow and Astronomer Airflow to Kubeflow. However, the prerequisite for the part 2 is the Kubeflow pipeline. This is the repository path. Let's get in there. And then the steps are outlined here. Some of these already have been covered in the last video, which we called the Kubeflow pipeline from Airflow. So if you have followed that, you may have already this setup ready. In case you have not followed, it's good to start from the beginning. The first step is creating a Kubernetes cluster. I'll be using kind. And the second part is once the Kubernetes cluster is available, we're going to set up the Kubeflow and Kubeflow pipelines. And then finally, we'll do the port forward from 80 to 8081. So in our localhost, we'll be able to access localhost colon 8081 to access the Kubeflow pipeline UI. Third step would be the ML pipeline that we're going to build. It will have a couple of steps. Step 1 would be pre-process, second step would be train, next would be test, and the last would be deploy, right? So there are 4 steps, and then in order to be able to run from Kubeflow, for each of those steps, we'll have to Dockerize, create Docker images, and we'll publish them into the Docker Hub. There are references towards the end. You can go through at your convenience. So let's start with the Kubernetes cluster creation. Now, some of these steps are very, very time taking, and I have already created the cluster, and I'll show you that. If you open Docker for desktop and filter for kind, you can see them. The cluster is created here, and then if you look through that particular, so the namespace is Kubeflow. I want to list on all the pods in there. So the cluster is up and running. Second step is also done. The third step would be just looking at the context. Yeah, the cluster is running. So this is done. Let's move towards the Kubeflow setup. For this, we need to run this particular script, kubeflow setup.sh. I have copied this from the Kubeflow web page. You can see that in the repository as well. Let me show that quickly. Kubeflow setup.sh. Okay. It's good to check out that repository and make it available within in your local system. I have opened that from PyCharm IDE. If I expand the Kubeflow pipeline folder here, you can see the script kubeflow setup.sh. Here what we are doing is we are disabling the cache in Kubeflow pipeline. If you don't disable the cache, then let's say if you're running the pipeline multiple times and there are no changes in any of those steps in your pipeline in the subsequent runs, then the subsequent run will completely skip and it will take the previous execution from the cache, previous pipeline execution steps from the cache. Just for the demo, I wanted to show you, no matter how many times I'm running that same pipeline, every time it will run each of those steps. It will not take from the cache. So that is how I disable the cache here in Kubeflow pipeline. This is the step that is doing so. If you want to enable it back, you can comment this line and then you can uncomment this line. Okay. Here it is setting up the Kubeflow pipeline. So I've run this step already. Let's go to the terminal and then I'll do the port forward. How do you confirm, if the Kubeflow pipeline has been set up or not? If you look at this by running this command, you can see the ML pipeline and all those components of the Kubeflow pipeline are up and running. Next, let me do the port forwarding. So earlier it was running within pod, it was running in 80 port. Now it is running in 8081. Let's check from the browser. You can just localhost 8081. There you go. These are some template pipelines. I'm not bothered about them. If you expand the experiments, right now it is empty because we have just set up the Kubeflow pipeline and we have not run any ML pipeline or Kubeflow pipeline in this as of now. Let's do that. Go back to the IDE and not this one, KFP pipeline .py. If you run this, it will run that pipeline in the Kubeflow. Let's try that. If there are errors, then you will get that error in the term console here. Okay, so the invocation has happened. If you go back to this, just refresh this. Can you have browser refresh or there is a refresh button here? Normally it does not take so much of time. Expand the default. You can see California housing pipeline has been triggered. We'll let it run. We'll come back to this. Let's go back to the code. So what is really being done here? So there is an annotation DSL.pipeline. That's how, like you saw in the Airflow DAG definition, this is basically the pipeline definition in Kubeflow. That's the annotation that you'll have to use. Provide a name and description, and the function California housing pipeline. And if you correlate that back to this in Kubeflow, that's what you see. 15th August 2025 when it was invoked. Right, that's the name it picks up in the Kubeflow. You can see the steps: pre-process, operation, train operation, test, and deploy model of. Okay. Let's see how they're imported. AP pre-process component. Let's go to the pre-process component. So there is a definition of the pre-process component. Return DSL.container of, that's the construct that you have to use. You can give it a name, image. I'll explain from where how we're picking this image. Arguments and file output. So in this case, there are no arguments. However, there are file outputs that you're going to generate and they'll be named by this key. And this is the location of where the training x underscore train will be present, where x underscore test will be present, and y underscore train and y underscore test. That's the first component. The second component, if you go back to the pipeline code, is train underscore op, and that is imported from KP train component. So let's get there. KP train component, right? In this, let's now look at the output that you generated in the previous step. So you generated train test for x and y. Here, if you see, those are being passed as arguments to the this particular component, right? This is a train operation. So train is taking x underscore train and y underscore train. It does not require the test because it's not really testing, right? It's just training the model. And the final output of the trained model would be saved by this key and this value. Again, I'll come back to the image part in a moment. So, and the other two steps, right, test and deploy, would also follow similar construct. You can just very quickly glance through this. So in test, we are taking three arguments, x test, y test, and model, and then it is generating a file output, mean squared error. The now that you're testing against the actual, true value, and based on what you have predicted versus what you had the actual value, you're creating the mean squared error, and you're persisting in this location. Yes. Last component is for deploy. Here you take that model as an argument, and that's what you want to deploy. All right. Those are the four components, and I promised I'll talk about the image in each of them. Right. Let's go to the first one, first component, which is pre-process, and there is a reference to this particular image. Let's see how those images are created. Now, the pre-process very first step, right? The actual work that you are doing is here. Is the pre-process step. In this, what you are doing, you are fetching California housing data. Again, that is from scikit-learn, and then you are splitting the data into xtrain, xtest, ytrain, and ytest, and then you are persisting. The this is how you are calling by the main method here. This step has to be dockerized, right? And that's what is being referred by the corresponding component for preprocess, which was KP preprocess component. So this is a reference to that particular image. But in between them, you have to have a step that can build that particular code, pipeline code for preprocess, this one, and then it will build the corresponding Docker image. Here is the Docker file for that, and we will run certain commands to create the corresponding Docker image. What would be the name of the Docker image? For preprocess, it would be sources dash kubeflow dash preprocess dash 2. You can give any other name that is suitable for you. And let's see what are the next steps. Okay. For some reason, it has failed. Let me just refresh it for once. For some reason, it is taking a lot of time. Oh, there are some errors here. You can see. The containers are in running state. Let me do the seems okay now. We can try running the pipeline one more time and see how it behaves. Some communication error that is happening. You can see here. We'll figure that out. Stop the service. I'll restart the Kubernetes cluster. The Kubernetes cluster has been restarted. We can check with the status of the pods. Seems good. Let's do the port forwarding one more time. I hope this time it goes through. Yeah, looks like positive. Let's trigger the pipeline one more time. Okay. So we will list it here under the experiments. Let this refresh. In the meantime, we'll explain the steps on how you dockerize each of the steps. First thing is pip install -r requirements.txt. So let's do that. You can open a terminal. If you are installing the KP uh, module for the first time, it might take a while. Next step is Docker login. Okay, I've already logged in earlier from this system, so okay. And this is my Docker Hub page. And next step is we're going to run this command docker build dot from the current directory -t services dash kubeflow dash preprocess dash t2 colon latest. Oh, here I forgot to mention the -f. That's what I was looking at. Let's do that. I'm going to invoke the preprocess Docker file. And you can see what it is doing. So it is taking the kubeflow pipeline process.py into the image, and then it is saying entry point is Python and will be running this script, Python space and the script. Right? That's what it is doing. Let's do that, and it's also installing the scikit-learn and numpy. Okay. And I forgot to mention the -f, and that will be Docker file preprocess. It is running different steps in the Docker file for the preprocess. You can see it has finished creating the Docker image for the preprocess step. Next step is to tag it. I'll tell you the reason why I have to tag this. So if you go to my Docker Hub, you can see The account goes by the name Suhasys Khatwa. So unless you tag them, right, with this particular step, you will not be able to upload that image that you have created into Docker Hub. This step is necessary. So what I'm doing is, this is my image name, and I'm tagging the image like this. Oh, this should be preprocessed too. Okay, so this is the image name. I'm tagging to this. Okay, so I'll format the command accordingly, and I'll correct that as well. You can see the step has been updated to the right image name. I may not be in the right path. Let's rerun the step. Let's tag the image. Push it to the Docker Hub. The image has been pushed to the Docker Hub. We can confirm that quickly. You can see it was 11 days ago. Okay, so now it is refreshed a few seconds ago. Right now, the rest of the images are there, right? So I don't want to execute each of those steps because these are slightly time consuming. I'll skim through. And once you have those images, you have seen that, right? You can invoke the pipeline by just calling this kp pipeline from here, run it. And once you run it, if you come to the Kubeflow, you can see the execution and you can see the corresponding log. So click on each of the steps that for which you want to see the log. You can see pre-processing data. You can tally that with our actual pre-processing code itself. Pre-processing data, and then it invokes that pre-process data method and sets those arguments, right, for the next step. Next step was train. So here the actual training would happen, and then finally you'll see generated model. Right? It will start with training model and it will end with generated model. So let's go back and see if we are able to see the training steps. It starts with training model and it ends with generated model, and in between the training step happens. Likewise, test model and then deploy model. That's pretty much it what I wanted to cover. So once you have this pipeline ready, right? Once you have this pipeline ready, you take all of this code into the Airflow, you place them under DAX folder, and that's the part that we have covered in our part 2 video already. Whatever files that we just ran that Kubeflow pipeline, if you want to run them from Airflow tag, you have to copy those files into the DAX folder of the Airflow, and then If I just go to Kubeflow 2, this is where you are calling the call Kubeflow pipeline. I have made a slight modification in the KP pipeline here. Okay. So instead of calling the client in the main code, I've put them in a function and I'm calling that function from the airflow DAG. And this airflow DAG then will call this particular Kubeflow pipeline, California housing pipeline that we just saw. That covers the prerequisite step for how you can call a ML pipeline that is built using Kubeflow. How do you call that from the airflow DAG? Thanks everyone for watching.